There's two main properties we use to solve equations. The first one is called the addition property of equality, and it tells us that we're free to add the same number to both sides of an equation anytime we want, and it won't change the solution. Let's try it with our first problem. I have x minus 5 is equal to 3. What I want to do is solve this for x. So I want x by itself. What I'm going to do is add positive 5 to both sides of the equation, and that way negative 5 plus positive 5 will be 0. So x minus 5 plus 5 is equal to 3 plus 5. Now that's the addition property of equality. I've added 5 to both sides of that equation. Now x plus negative 5 plus 5 is equal to x plus 0, which is just x. And on the right side I have 3 plus 5, which is 8. Now I know that you can solve that equation, of course, just in your head. So you don't have to worry about using the addition property of equality, but we want to show it on some of the simpler problems so that you get used to it. Let's look at problem number 2. I have 7 equals 4a minus 1. I want to solve this for a, so I want a to be isolated on one side of the equation. I'll start by getting rid of this negative 1 right here. So 7 plus 1 on the left side, 4a minus 1 plus 1 on the right side. Now that's my addition property of equality. I've added 1 to both sides of the equation. Now on the left side here, 7 plus 1 is 8. And on the right side, I'm going to have 4a plus negative 1 plus 1, which is 4a plus 0, which is just 4a. Now that brings me to my second property, which is the multiplication property of equality, which says I'm free to multiply both sides of an equation by the same non-zero number anytime I want, and I won't change the solution to that equation. That allows me to take this 4a and replace it with just 1a, so I have my a isolated on this side of the equation. To do that, I'm going to multiply by the reciprocal of 4, which is 1/4. So 1/4 times 4a on the right side of the equation. If I multiply the right side by 1/4, I have to do the same thing to the left side. So 1/4 times 8. Okay, 1/4 times 8 is going to be 2. And then 1/4 times 4 is 1, times a is just a. So this equation solves to just 2 is equal to a, which is the same thing as saying that a is equal to 2. So in that second equation, what I did is I used both the addition property of equality and the multiplication property of equality. Let's look at our third equation. 2/3 x is equal to 8. I want to solve this for x. I notice that I have 2/3 x on the left side. I want just 1x. So I'm going to multiply this left side by the reciprocal of the coefficient of x. So 3/2 times 2/3 x is equal to, that's right, 3/2 times 8. If I multiply the left side by 3/2, I have to multiply the right side by 3/2 also, and that is the multiplication property of equality. 3/2 times 2/3 is 1, times x is just x. And then 3/2 times 8, I'll just divide 2 into 8. That's 4, and then 3 times 4 is 12. So a simple little problem with fractions there, and I end up with just x is equal to 12. That's the solution to this equation. If I replace x with 12, this simplifies into a true statement. So I use the multiplication property of equality again to multiply both sides of the equation by the reciprocal of the coefficient of x. Let's look at our fourth problem. I want to solve 5 minus 2x equals 3x plus 1. 5 and 1 are constant terms because they don't contain the variable. 2x and 3x are variable terms. I want all the variable terms on one side, constant terms on the other side. I'll begin by adding negative 3x to both sides of the equation. When I do so, I end up with 5 minus a negative 2x plus negative 3x is negative 5x equal to 0. That's 3x plus negative 3x plus 1, which is 1. Now I'll add negative 5 to each side of the equation, and I'll end up with 0 plus negative 5x is equal to 1 plus negative 5, which is negative 4. Next, I multiply both sides by negative 1/5, so I'll have just 1x on one side, on the left side. If I do that to one side, I do that to the other side also. So I have negative 1/5 times negative 5x, which is positive 1x. Negative 1/5 times negative 4 is positive 4/5. So my solution to this equation is x equal 4/5. I use two properties of equality to find this solution. The first is the addition property of equality, which says I can add the same number to each side of an equation and I won't change the solution set. And the second is the multiplication property for equalities that says I can multiply both sides by any non-zero number I choose, and that won't change the solution set. All the equations that you see here are equivalent to one another. The last one is just the easiest one to read, and it says x is equal to 4/5. Here's another example. This time I'm going to have to remove these parentheses by multiplying through here by a -5. So I'll do that. I'll have 3 plus a -5 times 2m is -10m. And then -5 times -5 is +25. So I apply the distributive property first to separate the terms here so I don't have any parentheses left. Now I'll simplify a little bit more. This is -10m plus 3 plus 25 is 28 is equal to -2. Here I have all my variable terms on the left side, -10m. So I'll add -28 to both sides to get rid of this constant term. When I do that, I have -10m is equal to -2 plus -28, which is -30. When I add -28 to both sides, here I multiply both sides by -1/10, which is the same really as dividing both sides by -10. When I do that, I end up with just 1m is equal to +3. So again, I use the same rules that I used on the previous problem, the addition property of equality and multiplication property of equality, after I simplify both sides of this equation first. And I do that by first using the distributive property to separate the terms. Then I combine these two terms here to get 28. I want to do that before I add the same number to both sides and multiply or divide both sides by the same number. Let's look at a problem now that involves fractions. 1/2 x plus 1/4 equals 1/3 x plus 5/4. You can work with these fractions if you like, or if you want, you can get rid of the fractions by putting in another first step where we multiply both sides by the least common denominator for all the denominators you see. That would be the number 12. I'll multiply this side by 12 and multiply this side by 12. And here I end up with 12 times 1/2 times x, which is 6x. 12 times 1/4 will be 3. And here, 12 times 1/3 x will be 4x. And then 12 times 5/4, well, 4 will divide into 12 3 times 5 is 15. So 5/4 times 12 is going to be 15. Now I'm left with a nice simple linear equation in one variable. I can add -4 to both sides, add -3 to both sides. It'd be pretty easy to solve this. Adding -4x to both sides, I get 2x plus 3 is equal to 15. Add -3 to both sides, and I have 2x is equal to 12. Multiply both sides by 1/2, and I have x is equal to 6. Now, I could have worked the same problem just leaving the fractions here, and I'd end up with a lot of fractions. I think a lot of times it's easier if we clear the equation of fractions first. Here's a problem that involves decimals. I'll do the same type of thing here. I can work with the decimals if I want, or I can also multiply both sides by a power of 10 that will remove the decimals. So since I have 0.35 here and 0.15 here, I'll multiply both sides by 100. So 100 times 0.35x is 35x. 100 times 0.2 will be 20. And then here, 100 times 0.15x is 15x. And 100 times 0.1 will be 10. Now, if I add -15x to both sides, I'll end up over here with 20x. And if I add +20 to both sides, I'll end up on the other side with 30. Divide both sides by 20, and I get x is equal to 3/2. 30 divided by 20 is 3/2. So that's a look at solving some linear equations in one variable using the addition property and multiplication properties of equality.